know that using matrix algebra, you can write a linear equation system in this form. AX equals D, where A is the coefficient matrix, X is the vector of variables, and D is a vector of right-hand side constants. And let's assume that this matrix A is a square matrix, okay? Let's just assume A is n by n. Let's assume X is n by 1 and D is n by 1. In other words, we're assuming we have n equations, n linear equations, and n variables. Okay. And we want to know whether or not we can solve this equation system and how we can solve it. Whether or not a unique solution exists to this equation system. Well, suppose we know what this coefficient matrix is. And suppose we can find its inverse. Okay, suppose we know what the inverse of matrix A is. Then if we could find A inverse, let's multiply both sides of this equation by A inverse and see what we get. A inverse times AX equals A inverse D. And what is A inverse A equal to? Somebody said it. The identity. So then we could write this as IX equals A inverse D. And we could just delete this identity and make it even simpler. And let me put a star on the X now to indicate this is the solution value. The solution value for the X vector is just A inverse D. What this means is if you could find the inverse of the coefficient matrix, if you know what the right-hand side vector of constants are, you just multiply the inverse times the right-hand side vector, and out pops your solution value for every one of the x's. Remember, this is x star is n by 1. So you get x1 star, x2 star, x3 star, da da da, xn star. Okay. So that's why we're so interested in this inverse matrix. Okay. We learned that the inverse, if it exists, is unique. We proved that last class period. So that means if the inverse is unique, if there's only one and only one inverse corresponding to any coefficient matrix, then that means your solution to this equation system will also be unique. Because the solution is just A inverse times D, and there's only one of these A inverses corresponding to any A. There's a given D vector, so you do this multiplication and out pops your solution, and you know that that solution is unique because of the uniqueness of the inverse. Okay, so if the inverse exists, then you can get a unique solution to the equation system. And this unique solution is just the product of the inverse matrix and the vector of right-hand side constants. So now we have a systematic procedure for solving a system of linear equations.